In this video, we're going to take a look at how we can find key features of our sine and cosine functions when given their equations. So a couple of the features that we're going to look at are the period and the amplitude. The period is just the length of one cycle. And generally, we know that the parent functions, y equals sine of x and y equals cosine x, have a period of 2 pi. But that can be changed by having horizontal compressions or stretching, right? And then the amplitude is just the height of our curve, or the distance from the midline of our curve to the top or bottom, to the maximum or minimum values. So let's take a look at how we can actually calculate these when given the equation. So if we're given these general equations, y equals a times the sine of, this is omega, this is the Greek letter omega, y equals a sine omega x plus b, or y equals a times a cosine omega x plus b, we can find the amplitude, period, and midline in this fashion. So the amplitude is just the absolute value of the leading coefficient of a. Now the reason why it's the absolute value is because, again, remember, amplitude is a distance, and when we're talking about distance is always going to be a positive value. The period is 2 pi, the normal period of the sine and cosine function, divided by omega. So essentially what omega tells us is how many cycles are going to happen in our sine and cosine function in 2 pi radians. So in a normal sine curve, omega is 1, which means we complete one full cycle from 0 to 2 pi. And then the midline is essentially just our vertical or horizontal shift. And so it's whatever the value of b is. So if b is positive, it's shifted up. If b is negative, it's been shifted down. And the midline is going to have an equation of y equals b. So if there's been no vertical shift, it's y equals 0, and it's just going to be the x-axis. So let's actually take a look at calculating some of these. So we want to determine the amplitude, period, and the midline for this function without graphing. So to find the amplitude, we know that the amplitude is just the absolute value of a. So a is -6, so it's the absolute value of -6, which is going to give us +6. So what this means is that the distance from the midline to the maximum or minimum of our graph is going to be 6 units. To find the period, it's 2 pi divided by omega. Now we know omega is pi in this case, so we get 2 pi divided by pi, and we get a period of 2 whole units. It's not in terms of pi in this case. Now, because our function doesn't have anything being added here, it really means we're adding a 0. So our midline is going to be the equation y equals 0. So its midline is just going to be the x-axis. One thing that I forgot to mention, but is worth noting, the period is also a distance. It also measures a distance, right? It's the distance that it takes to complete one cycle. So your period will never be negative. Your period will never be negative. Let's take a look at one more. So we want to, again, determine the amplitude, period, and midline of our function without graphing. So the amplitude, we said, was the absolute value of a. So this is our value of a. So absolute value of 3, which is just 3. So that means the distance from the midline to the maximum or minimum values is going to be 3 units. The period is found by taking 2 pi divided by omega. In this case, omega is 1/4. So we have 2 pi divided by 1/4. Now remember, when you divide by a fraction, we keep the numerator the same, so 2 pi, and we multiply by the reciprocal of the denominator, so 4/1. So do this product, and we end up with 8 pi, which means it's going to take 8 pi radians in order for us to complete one cycle, or we only complete 1/4 of a cycle from 0 to 2 pi. And then lastly, the midline the equation of our midline is y equals -2, which means this graph has been shifted down 2 units of our normal parent function.